Okay, talking further about methods, titration is a common one, and I know a few of you may have some questions regarding this. So, first of all, at titration, we've got three pieces of equipment that you need to remember. We've got the burette, the pipette, and a conical flask. Which chemical is going where? Is it going in the pipette or is it going in the burette? Okay, so I'll show you my bullet points there. Okay, these are the three bullet points you want to consider. What's going in the pipette, what's going in the burette. And the way to determine that is, remember, if they don't already tell you that in the question, that is, it won't necessarily be acid is always in the pipette, and it won't necessarily be alkali, maybe always in the burette, or however you've done it in school. The best way to determine is look at the pipette and see in the question which one has the set volume. Okay, so a pipette, unlike the burette, can only measure one volume. Now 90% of the time this is going to be 25 centimeters cubed. Okay, 90% of the time. But you can get pipettes which are maybe 10 centimeters. Okay, and I have seen that in a question before where the pipette was 10 centimeters and it threw a few students. So the pipette has one set volume. So whichever chemical where it says measure 25 centimeters cubed or whether it says measure 10 centimeters cubed, a specific set volume, that is the pipette. Okay, and the pipette looks like this. Yeah. Now, what goes in the pipette eventually goes into the conical flask. Okay, and that's important because the conical flask is where you first put the indicator. So point 3, the chemical in the conical flask determines the set color of the indicator, sorry, the start color. Therefore, the chemical in the pipette determines the start color of the indicator. Given what goes in the pipette is then going into the conical flask. This conical flask would then be moved underneath your burette, okay, where you slowly add the contents of the burette, and the indicator will gradually change. Okay, the burette, different to the pipette, can hold any volume below 50 centimeters cubed. So this will be the chemicals which have different volumes, and this essentially is what will be known as the titer. Okay, the one that you keep repeating. So it should have a few different readings. Okay, so looking at what goes in the pipette and the conical flask, that then, point 3, will help you to determine the indicator color change, because that will be usually worth 1 mark. So just to highlight that, if we go over here, the indicators are shown, so pH 14, so this is when it's a base, and this is when it's acid. Okay, these are the colors of the indicators. This is supposed to be colorless, by the way. So if you start with acid in the pipette, so acid in the pipette, therefore meaning acid in the conical flask, when you put the indicator in, for methyl orange, it's going to start as this color. This is the starting color for acid, and as you add the chemical from the burette, the color is going to gradually change into this. Okay, doing the same for the phenolphthalein. If we start with acid in the pipette, so therefore acid in the conical flask, okay, so we're still looking at this column here. If acid is in the conical flask, therefore the indicator is going to start as colorless, and it's going to gradually change to pink, and that can be seen here, colorless to pink, so that will be your color change. Okay, now if we start with alkali in the pipette, therefore alkali in the conical flask, it's going to be the opposite. So we're going to start with this color, yeah, and so for methyl orange it's going to start as yellow and go to orange. So start as straw yellow and it's going to turn orange. And for phenolphthalein, it's going to start as pink and turn colorless. Okay, so that indicator at the end, the color change, it does matter and you will be penalized if you say the wrong color change. Yeah, so just remember, whatever's in the pipette goes in a conical flask, and that determines the starting color of the indicator. This 0.3, and this table should help. So if acid was in the pipette, it's going to start as orange or colorless, and it's going to go to straw yellow or pink, depending on whether it's phenolphthalein or methyl orange. And the alkali in the pipette will start as straw yellow and turn orange for methyl orange, and for phenolphthalein it will start as pink and turn to colorless. The other thing that you should remember, a few things to add in any titration: always say this statement, add contents of burette slowly, even if you don't know whether it's an acid or alkali. Okay, just add the contents slowly. Near the end point, add drop by drop. Okay, drop by drop being the crucial statement there. Drop by drop. Use a white tile. There's something else you should say, and 3 drops of indicator. Okay, so hopefully that will help you answer a titration question. For the method, that is. It won't help you with the calculations. Thank you.